So if we're going to compare the results that we got in the lab to the actual known value, that comparison to find out if we do a good job, we answer that question by finding the percent difference. We can also call that, what is our experimental error? Or a kind of a mashup between those two terms, percent error. Any of these terms is what I'm about to show you now. So I'm going to tell you what the actual value of the density of your clay is, or the correct value of the density of your clay is, or the actual, correct, theoretical. What's another term that means the same thing? We're going to compare the actual, the correct, the right, the theoretical value to what you, as an experimenter, measured, observed in the laboratory. These story problems that you're going to get, they're going to use words like this, and you have to know where to put them in the equation. True is another word. The true value of the density. The correct, the actual, the theoretical. The measured, the observed. Those are two different things, and you're going to compare them by doing a percent difference calculation, which is this. Percent difference, or percent, I'm going to say percent error, is equal to the measured value, the observed value, minus the actual value, divided by the actual value, times 100. All right, now I'm going to put some symbols here so that we get things in the right order. Have you guys talked about absolute value? Okay, so I need to put these bars up at the top. That means absolute value. I'll make them big and dark so you don't think it's an L or an I. All right. And then it's important that I put these brackets here because I want you to do this first before you multiply it times 100, okay? This is called the percent error. What we found as our experimental value over here, our experimental density, our measured value, was equal to 1.02. Proper units would be grams per milliliter. We know that the actual value of the density of water is 1.00. By definition, hang on. By definition, the density of water is 1 gram per milliliter. I don't know whether they took a gram of water and then put it in a graduated cylinder and said, okay, this is a milliliter, or whether they took a milliliter of water and then they put it on a scale and said, okay, this is a gram. But in either case, 1 gram per millimeter, by definition, is the density of water, and that's probably how they set up the whole metric system. So by definition, that's what the value of the density of water is. That's the actual, the correct, the true, the theoretical. But in the lab, this person who left their paper on the floor without a name got a value of 1.02. Is that good? Ethan's already plugged in the numbers. So if I plug these in here, our measured value is 1.02. Our actual value is 1. Absolute value, you don't have to find an absolute value button on your calculator. All I'm going to say is if you get a negative answer out of this, make it a positive. Let me say that again. If you do this calculation and you get a negative, make it a positive. That's all I mean by absolute value. Divided by your actual, and times 100. And Ethan, what do you get? 2%. 2% for a high schooler in a college lab is really, really good. 2% for a high schooler in a high school lab is really, really good. Anything less than 5% experimental error is pretty doggone good. If you get between 10 and 20% or more, that's not very good. If you have 20% experimental error, you have some explaining to do. I'm not saying what you did was wrong, but you need to explain why what you did in the lab is so different than what we thought we were going to get. For example, let's just say we were doing a unit on rockets, and we were going to launch rockets out in the field over there. And the manufacturer of the rocket engine said, with this rocket engine and this rocket, your rocket should go 150 feet in the air. Not very high. But if we launched the rocket and then we measured the altitude of the rocket and we only got 100 feet, then our measured value was 100, our actual value, or true or correct or theoretical value was 150. We're looking at like 30% experimental error. We got some explaining to do. So if you wrote up a lab report and said, hey, I think I did a pretty good job, my rocket went 100 feet when I was supposed to go 150. You have to explain why. Mr. A, on that day, if you will remember, the wind was blowing 10 miles an hour. So instead of the rocket going straight up and no wind, the rocket kind of went over a little bit. That would explain it. So this is why we deal with experimental error, percent difference, so that we can judge how well we've done in the lab to what we should have got in the lab. This person who got 2% experimental error, I'd really like to know who that person was, and I think they came from this class. Really, 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 really good techniques. That's the only way you can do it, by reading really, really close. All right. Question? Okay.